So in this worksheet, our job is to classify each alkene as either cis or trans, or if it's sometimes the case, a molecule that cannot be classified as cis or trans. So when we are doing this, we're going to start by focusing on the double bond, and let's just go ahead and draw a line all the way across the double bond so that we can identify the sides of the double bond. And because we're working with line structures, I like to draw in any hydrogen atoms that are missing from the carbon atoms, just the ones that are part of the double bond. I don't need to see all the rest of the hydrogen atoms, just those ones right there. The reason that I like to look at the hydrogen atoms is because they are usually what I'm going to look at when I'm trying to decide if the molecule is cis or trans. So I drew these hydrogens in, and I can see, if I'm looking at my line of my double bond, I can see that one of my hydrogens is on the top and one of my hydrogens is on the bottom. So these are hydrogens on two different sides, which means that this molecule is the trans isomer. Let's go to our next example. First, we want to really draw a nice line through our double bond so that we can identify the two sides. And then next, I like to draw in any hydrogens that might be on that double bond, because the hydrogens are easy to look at, easy to find and compare. I have two hydrogens, and those two hydrogens are on the same side of the yellow line, which makes this a cis isomer. Moving on to the next one, draw a nice line through your double bond so you can easily see the two sides. And now what we need to do is, we don't have any hydrogens missing from this double bond, so what we need to do is find something on this carbon that is also on the other carbon. Chlorine we can't use because it is only on the left-hand carbon. Likewise, bromine we can't use, it's only on the right-hand carbon. Sometimes students think, here's a carbon, I'll compare this carbon to this carbon. In doing that, I can come up with cis or trans. That, however, is not allowed. When you're comparing what's on the left, what's on the right, the whole identical thing needs to match. So you're looking at all of this branch, which is a CH3, compared to all of this thing over here, which is much bigger than a CH3. These two groups are not the same. This is not on the right-hand carbon, and this group is also not on the right-hand carbon. This particular molecule has nothing in common on its double bond. This is not a molecule that we can classify as cis or trans. Next example, draw a nice line through your double bond. And this one we do have some hydrogens that we can draw in. And here we are looking for something that's on this carbon that's also on this carbon. We have a hydrogen, but our other carbon doesn't have any hydrogens on it. So we can't use hydrogen to classify. We have a CH3, but our other carbon doesn't have a CH3, so we can't use that to classify either. This molecule also has nothing that we can use to classify as cis or trans. Next example, draw a nice line through your double bond and add your hydrogens in. And whenever I have hydrogens, I like to try to use them for my comparison. This one, I have my top hydrogen, or my top carbon has a hydrogen and my bottom carbon has a hydrogen, and both of those hydrogens are on the same side of the yellow line. That means they're on the same side of the bond, so this is cis. Let's look at another one. Draw a nice line through your double bond. And let's look for what can we use to compare. Starting with this guy right here, we have a chlorine on our left-hand carbon. We also have a chlorine on our right-hand carbon. Perfect. The chlorines are on two different sides of the yellow line. They're on two different sides of the double bond. That makes this molecule trans. We have two more examples to go. Let's draw a nice line through our double bond and add in, we have one hydrogen to look at. So let's see if we can figure this one out. We have on our left-hand carbon, there's a hydrogen, but over here on our right-hand carbon, we do not have a hydrogen. So that means we cannot use hydrogen to classify cis or trans. Let's try this. This right here, we have a 2-carbon substituent, but our left-hand carbon does not have a 2-carbon substituent, so we cannot use that to compare. Again, we are looking for something on the left that is also on the right. Our 1-carbon substituent, methyl, we have one on the left, one on the right. They're on the same side, so this molecule is cis. And for our last example, let's draw a nice line through our double bond, and we've got a couple hydrogens that we can fill in. We're looking for something on our top carbon that is also on the bottom carbon. We don't have anything. Our top carbon has just 2 hydrogens. There are no hydrogens on the bottom carbon, which means that these 2 carbons do not have anything in common. This molecule is neither cis nor trans. The last thing this worksheet asks after you've classified them, name as many of them as you can. So what I want you to do is pause the video. See if you can come up with their names. When you think you've got them named, unpause the video. When you come back, I'm going to have all the names written up here for you.